Okay, derivatives involving inverse trig. So I'm going to put the long way up here. This is if we didn't have these shortcuts, or this is actually how you can come up with the shortcuts and kind of see a pattern. We're going to do this using what we already know. I do not know how to find the derivative of arc sine, but I can take the sine of both sides. So sine of y equals 2x. Do you know how to find the derivative of sine of y? I hope so. I know how. The derivative of sine of y is cosine of y times y prime. It's implicit differentiation. The derivative of 2x is 2. So the derivative of y is 2 divided by cosine of y. Now, a lot of times when we have a derivative, we don't want to use y. We want to use x. We want to use that independent variable that we started with, so we're dealing with an x. But in the review section, when we did those right triangles, we can figure out what the cosine of y is if we know this relationship right here, right? So if I set up my right triangle, the sine of this angle is the opposite over the hypotenuse, which makes this bottom side, the adjacent side, the square root of 1 minus 4x squared by the Pythagorean theorem. And then the cosine of y, which is really what I want to know, the cosine of y is this divided by 1. So I can rewrite this as 2 divided by the cosine of y, which is the square root of 1 minus 4x squared. So that would be the work if we didn't learn the shortcut. But the shortcut says that, and you can see that in the boxed section at the top of your notes there, that the derivative for the arc sine of a function is the derivative of the function, derivative of 2x is 2, divided by the square root of 1 minus the function squared. 1 minus this squared. It takes us right to the answer. We can skip all of this work in the middle. And then we have really two other rules. We have the derivative of arctangent. That's the derivative of the function divided by 1 plus the function squared. And then the derivative of arcsecant is the derivative of the function over the absolute value of the function times the square root of, notice the order, it's the function squared minus 1. So that's a big clue when we do antiderivatives. If the function is first and then minus the 1, that's usually going to be arcsecant. If it's 1 minus the function squared, that's going to be our arc sine. So let's use these shortcuts. Really, you're going to have to memorize them. If we were in class, definitely would have to memorize them. Since you're probably going to take the test and you might look at your notes, they're there for you. If you're ever going to take another calculus class in the future, though, you need to know those. By the way, the other three are identical to the first three, except you got a little negative sign. So arcsine and arccosine, same rules, cosine gets the negative. Arctangent and arccotangent, same rules, cotangent gets the negative. That's the C, okay? And then arcsecant, arccosecant are exactly the same, but the arccosecant gets the negative. So let's go ahead and do the shortcut with letter B. Letter B says that we're dealing with y equals the arc sine of the square root of x. Okay, the derivative for arc sine is the derivative of the function. So the derivative of x to the 1/2 is 1/2 x to the negative 1/2. The derivative of the function over the square root of 1 minus the function squared. If you square that, you get x. And now we're just going to simplify this. So we get y prime equals 1 over 2 square root of x. That would be this part. But since we're dividing by something else, that also is going to be in the denominator. And you could leave it like that. I mean, we could blend that together if you wanted to. We can make that, since it's a radical times a radical, the square root of x times 1 minus x. We could put them underneath. Either way is fine. So let's go ahead and try letter C. This one's arcsecant. I'm not going to do that long way anymore. I'm going to learn these shortcuts, these derivative rules, and then apply them. So letter C, y equals the arc secant of x squared minus x. So it's the derivative of arc secant. The rule says that it's going to be the derivative of the function, so that's 2x minus 1, over the absolute value of the function times the square root of the function squared minus 1. So that's the calculus of it. We could try to simplify that, but I'm going to leave that alone. Now, letter D. Looks fairly simple, looks like it might just be arctangent, and some of you are continuing to get caught on problems like that. That is a product. Letter D is a product. And whenever I have a product of functions, I have to use the product rule. So I have to use these rules. These are shortcuts from patterns. Letter D. X times the arctangent of x. So this is my first function. I'm going to make that u. This is my second function, v. Product rule is the first function times the derivative of the second. So the derivative of arctangent, we just learned the rule. It's the derivative of the function, which is 1, over 1 plus the function squared. So that's first times the derivative of the second, plus the second, which is arctangent of x, times the derivative of the first, which is times 1. So this ends up being x over 1 plus x squared plus the arctangent of x. We can make that one answer, one term, by multiplying this top and bottom by 1 plus x squared, or we can leave it alone like that. Letter E. Let's do letter E. Letter E is y equals the inverse sine, that's arc sine, just a different way of writing it, so that's still our arc sine rule, plus x times the square root, but I'm going to write that as times 1 minus x squared to the 1/2. Alright, so this is going to happen sometimes. This really gets into this integration stuff that we're going to do in the next video. We have a sum, so that's the derivative of the first here, derivative of arc sine, so derivative of the function, derivative of x is 1, over the square root of 1 minus x squared. So that's the first piece. The second piece is a product of two functions. So I'm going to multiply, or I'm going to use my product rule there. So it's the first times the derivative of the second. I need the chain rule. Derivative of this is 1/2 times 1 minus x squared to the negative 1/2 times negative 2x. And I'm running out of room, so I need to erase that other problem. Alright, so first x times the derivative of the second, that's chain rule. 1/2 times 1 minus x squared to the negative 1/2 times the derivative of the inside, so times negative 2x. But that's only half of my product rule. First times derivative of the second. Plus second, 1 minus x squared to the 1/2 times the derivative of the first, which is times 1. So this is the calculus step. Now we're going to do our simplifying. We've got some common denominators that are going to show up here. So I'm going to leave this one alone for now. This guy, okay, so 1/2 times negative 2 is negative 1. So we get a negative 1x squared over the square root of 1 minus x squared, because that has a negative exponent. It moves to the bottom. It's a square root of 1 minus x squared. And then I have plus the square root of 1 minus x squared. Now I can get that to have the same denominator by multiplying by the square root of 1 minus x squared on the top and the bottom. Okay? So now I can combine all of these into one answer. And I want you guys to see that, because this one answer, when I do the antiderivative, should take me back to something that looks like this. So we really got to know our stuff before we do that integration to be able to get this split up, and one to be an arc sine and one to be just a normal problem that we've done before. All right, so if I combine these, that's 1 minus x squared. When I multiply this, that's 1 minus x squared. And I'm adding these together, so I get 2 minus 2x squared all over that denominator. Okay? I can take a 2 out here. I get 1 minus x squared over the square root of 1 minus x squared. Okay, that's really 1 minus x squared to the 1/2, which, since we have the same base, that's a 1, that's a 1/2. We can reduce that even further. It becomes 2 times the square root of 1 minus x squared. Okay? So that derivative of this complicated thing actually became something fairly simple. So we got to learn how to go from this and go back and figure out, oh my goodness, the antiderivative of this is that? That's pretty complicated, but you'll be able to do that. Okay? I have faith. Just practice this derivative stuff and we'll get to it. All right, let's go ahead and look at letter F. These problems are taking up so much more space now. Letter F. Okay, we have the natural log of a function. We know that rule. Minus 1/2 times the arctangent of a function. We've just learned that rule. So let's go ahead and do this. Derivative of natural log is the derivative of the function 2t over the function t squared plus 4. Minus 1/2 times, that constant doesn't really affect how we do a derivative, so I can just keep it out front. The derivative of arctangent of a function is the derivative of this function, which is 1/2, over 1 plus the function squared, which is t squared plus, or sorry, t squared over 4. That function squared is t squared over 4. So we got some simplifying to do over here. This first piece, I'm just going to leave it alone. I'll carry it down as I work on it. This is the guy I need to simplify. So I'm going to multiply this fraction piece by 4 over 4. I'd like to get rid of the fractions inside of fractions. You can do that by multiplying by the common denominator in there. This 1/2 I'm going to stay. When you multiply by 4, you get a 2 there. You get a 4 plus t squared. I'm multiplying 4 times 1, 4 times this, gives me that denominator. That 1/2 and 2, that will reduce. So we have our first fraction, 2t over t squared plus 4, minus 1 over 4 plus t squared, or t squared plus 4. So that combines to be 2t minus 1 over t squared plus 4. That's that derivative answer. All right, letter G. We're just following our rules. No matter how complicated it looks, take your time, pick it apart. What's the inside function? What's not? Okay, you guys can handle that. I think I can fit this one on here. This one's actually a pretty small problem. So letter G. We have y equals the arctangent, tangent of negative first, same thing as arctangent, of sine of x. So this is the arctangent of a function. It's the arctangent rule. The derivative of the inside function is cosine divided by 1 plus the function squared. Okay, now you might want to try to use a trig identity here. Cosine squared plus sine squared equals 1, but 1 plus sine squared does not equal anything. So this is as much as we can do for that problem. That's letter G. All right, letter H just is a problem saying, hey, this other stuff that we have done in every single lesson, finding tangent lines, still appropriate. We still can ask that. We just have more functions that we're able to handle. So this says to find an equation for the line tangent to arc cotangent of x. So the function I want to write a tangent line to is the arc cotangent of x. And that gives me to do this when x equals -1. All right, now when I write a tangent line, I need to know the x and the y. So if x is -1, okay, the arc cotangent of -1, the angle whose cotangent is -1 is 3 pi over 4. So that would be the y value. Now I have my x and my y. All I'm missing for my tangent line is the slope. The slope is found from the derivative. So the derivative of cotangent, it's the derivative of tangent but negative, okay? Derivative of tangent is the derivative of the function over 1 plus the function squared, but it's negative, okay? If you plug your x in there, you actually get undefined. No, you don't. I forgot to square the negative. All right. So if you plug -1 in and you square it, that's +1. So you get -1 over 2. Okay. So that's our slope. Okay. Tangent line would be y minus the y value equals the slope times x minus the x value. There's your tangent line. Okay. So we learned these new rules. Practice the homework, get comfortable with them, try to memorize them. So as you're working on the homework, try not to look, try to do them without, and then check, make sure you got the setup, try your simplifying. All right? Good luck. Join Zoom meetings if you have questions. See you later.